Second section for tonight is section 4.3, and it's called adding and subtracting polynomials. So I have still been uploading videos of our lessons from our lessons. Has anyone been watching those? Does anyone know? Are they working okay? Can you hear me okay? Everything sounds good? I started using this external microphone, and I think the voice is coming out a little bit more clear, but just when you're studying or if you ever miss class, you have that resource for you. All right, so let's go ahead and take a look at this. To get started, I wanted to talk about some vocabulary terms. The first thing is called a polynomial. A polynomial is an expression whose variable powers are whole numbers. A whole number would be like 0, 1, 2, 3, and so on. It's important that we know what a term means. A term just means a number, variable, or combination separated by a plus or minus sign. We'll also be talking about what's called an algebraic expression. An algebraic expression is a term or multiple terms being added or subtracted. A degree is just the highest power of x and then the word coefficient is just the number being multiplied by a variable. What I wanted to do is just make a table to go through some examples of these. So I'll put the examples on top. We'll list what's called the coefficient on the bottom, and then we'll also have the degree. So if we had the expression 3x to the 7th, the degree would be 7 and the coefficient would be 3. If we just had the term -6, -6 doesn't have an x. We would say the degree is 0 and the coefficient is just -6. -6, if there is no x there, just so you know, it's really just x to the 0 power. We talked about before, anything to the 0 power is just 1. What if we had x over 4? Does anyone know what the coefficient for this would be? It's a little tricky. It wouldn't be 1. 1 over 4 is the right answer. This is the same thing. If you divide by a number, that's the same thing as multiplying by the reciprocal. What that means is dividing by 4 is the same thing as multiplying by 1 over 4. So if that's the case, the coefficient's 1/4, the degree would be 1. And what if you had x to the 1/2? This is actually a trick question. This is not a polynomial because the 1/2 is not a whole number. Let's talk about something called standard form. Standard form just means that we write in descending powers or degrees. Actually, I just thought of another example. I would like to just add one thing to the chart. So if you still have room in your notes, let's just add one other example. What if I asked you 3 to the 4th? Does anyone know what the degree of that would be? It's a trick question. There's no x there, right? There's no x, right? So degree just means the highest power of x. This is the same thing as 3 to the 4th times x to the 0. Whenever we're talking about degree, we're talking about the power of the variable. So don't get tricked by that. The coefficient would just be 3 to the 4th, which is just 81. I just thought of that, and it's important to have that in our notes. All right, so shifting gears a little bit, I would like to go back to what we started with standard form. Typically, when we write polynomials, we go from the highest power of x down to the lowest. So if we had a problem where it was, let's say, -3x to the 4th plus 2x to the 3rd plus x to the 5th minus 6x, and we want to write it in standard form, what we would do is we'd write the highest power of x down to the smallest. So we would just write this x to the fifth minus 3x to the fourth plus 2x to the third minus 6x. That would be standard form. This right here is called the leading term. This right here is the degree. And this right here, the 1, is called the leading coefficient. All right. So that's that. Let's move on to something a little bit different. Let's talk about classifying polynomials by their number of terms. So let's say we have the number of terms, and we'll just go from 1 to 3. I'll tell you what the name of it is. I'll give you an example, and we'll talk about the degree. All right, so let's say we have one term. Say we have 3x squared y. That's one term. There's no plus or minus signs. One term is called a monomial. What would be the degree of this? We haven't actually discussed this together, but when you have one term, you add up the variable powers. So when you have the degree, you add the variable powers. 2 plus 1 is 3. If there's two terms, it's called a binomial. This would be like 2x to the third minus 4x. The degree would just be, it would be 3. You go with the highest variable power here. So the highest power of any term is just 3. And then if there's 3 terms, we call it a trinomial. Trinomial would be like x to the second plus x plus 2. The degree for this would just be 2. If it's just one term. If it's one term, you add up the variable powers. All right. So I wanted to do a couple examples with this. What if I ask you to classify by the number of terms? And then give the degree. So let's say we had an example, a to the fourth, b to the second, minus a b to the sixth. Yeah, so this is a binomial because there's two terms. Yeah, this is a binomial, so that it's called a binomial because there's two terms. The degree of each of these terms, 4 plus 2 is 6, and this would be, what would be the degree of the second term? 7. So the degree of the whole thing, you go with the highest power, which would be 7. So if it's one term, you add them. You don't add them if they're separate terms. Does that make sense? Yeah. So an example would be like, what if I asked you, what's x squared plus x to the fourth plus 2 to the eighth? How many terms are there? There's 3 terms, so we call it a trinomial. All right, so I tricked Laquan. All right, the degree is just the highest sum of the variable powers. So the degree here would be 2, the degree here would be 4, the degree here would actually be 0 because there's no x. So the degree for the whole thing is just 4. Does it make sense when we add powers? Are you guys okay with that, George? Does that make sense, or are you still confused? You're okay now? All right. And then the last example was like negative 100. It's called a monomial because there's a single term. What would be the degree of this? 0. If there's no variables, the degree would just be 0. What I wanted to do to finish up class, we have about 10 minutes or so left. I wanted to add and subtract these, and then that'll be it. So now that we know what degree means, we know how to classify based on terms. The last few problems I want to go over with you, I'm just going to ask you to combine like terms, which is the same thing as me just asking you to simplify. So that word simplify just means combine like terms. A like term is just the same variables to the same powers. So let's say we had 2z to the fourth plus 3x to the fourth plus z to the fourth minus 9x to the fourth. We have all different terms. What we want to do is combine the terms with the same variable and the same power. So if you see, we have z to the fourth here, we have z to the fourth here. 2z to the fourth plus 1z to the fourth is 3z to the fourth. 3x to the fourth minus 9x to the fourth is negative 6x to the fourth. What if we had 5x squared z minus 3x to the third z to the second plus 8x to the second z plus 12x to the third z to the second? Well, they have to have the same variable and the same power. So this has x to the second z. I see another x to the second z over here. So this would be 5 plus 8 is 13, x to the second z. We have x to the third z to the second. This would be 9x to the third z to the second. So we're looking for the same variables with the same powers. So it's all one term. So the actual term is x to the third z to the second. If there was a plus in between, then you were right. The actual term itself, that's one term. If there's no plus or minus in between them, that counts as just one thing. Does that make sense? All right, let's do a couple where we're adding and subtracting, and I think that'll be good for today. What if I asked you to do negative 5p to the third plus 6p to the second plus 8p to the third minus 12p to the second? What we want to do is get rid of the parentheses. So we could just distribute that imaginary 1 in front to get negative 5p to the third plus 6p to the second plus 8p to the third minus 12p to the second. And then we combine like terms just like we did before. So anytime we have a p to the third, we can combine those. 3p to the third, and we have the p to the seconds. 6 minus 12 is negative 6p to the second. All right, we'll do one with subtraction. What if we had 2x to the third minus 3x to the second minus 2x plus 5. And I've seen it written like this in your book. I'm not sure if my math lab is like this too, but sometimes what they'll do is they'll just write it on top of each other, and they'll write minus 4x to the third plus 6x to the second minus 5x plus 8. There's a couple different ways we could do this. I don't really like the first way. I think it's prone for mistakes. One way we could do this is to just remember we're subtracting. So 2 minus 4 is negative 2x to the third. Negative 3 minus 6 is negative 9x to the second. Negative 2 minus negative 5 is negative 2 plus 5. And then 5 minus 8 is negative 3. I don't really like that technique where you just do it top minus bottom. I think that way you run the risk of making mistakes. The way that I would rather you do this is write it out like this: 2x to the third minus 3x squared minus 2x plus 5, and then subtract that whole second thing inside parentheses. Like this. If you write it out sideways, you could distribute the negative and you're less likely to make mistakes. So we just write 2x to the third minus 3x squared minus 2x plus 5 minus 4x to the third minus 6x squared plus 5x minus 8. And from here, we could just combine like terms. We have an x to the third, we have another x to the third, we get negative 2x to the third. We have an x to the second, another x to the second, we could just add those. Negative 9x to the second. Negative 2x plus 5x is 3x. And then 5 minus 8 is negative 3. You get exactly the same answer. I just think it's much easier to write it horizontally and then distribute the negative.